Hello everyone, this is Imtiaz. A few days ago, I uploaded this particular presentation on my LinkedIn, and then few more after that. A couple of my friends reached out to me and they asked me if I can make a video going through the slides, so it will be easier for for them to understand. So this slide basically is coming from this book, which you see on the left corner of the slide. Basically, in this particular presentation, we will see how we can think about building a system. So whenever we think about building a system, uh, when we look at any of the existing architecture for YouTube or Netflix or anything, we feel like we get overwhelmed by seeing those lines and boxes and caches and sequels, like a lot of things going around, right? It sounds very complicated. So, and also looks very complicated. So idea is in this presentation is to go through each step. We'll take one step, a small step at a time, and design a system, right? And this is just kind of a very high level overview on thinking about designing a system. It doesn't go in depth of anything, but just to give you a foundation of a system design, right? So I move to the next slide now. Okay, so the title is scaling from 0 to 1 million users, and as I said earlier, that we should think about starting small, and as we face the problem, we add more layers or simplify the solution, well, like find a simpler solution. And as one of the Chinese philosophers said, a journey of 1,000 miles begins with a single step. So let's do step one. So the idea is, let's say you want to build one website for your company, or you have, for something that you have developed, you want to build a website for that. A simpler thing you could do is basically register your domain name uh, at some of the domain name provider, and let's say assume you have one machine at home. You install the web server, you install your SQL server, and you have some website up and running. So, okay. So user comes to your website, they see the content and they're happy. And let's say your application, the website that you created became very famous and now you are getting more number of requests than you anticipated, right? So immediately you will see that you are facing performance challenge. So one thing you could do is basically move the database out from your server to another server. So basically now you have, instead of one machine, you have two machines or a dedicated DB server and you have a web server. And basically all the read writes is happening on DB and you query the database to get the data, right, based on what customer is looking for. Now, since we are talking about database, normally we'll see these days we talk about, hey, do you want to use a SQL server, like a SQL machine, RDBMS kind of database, or you want to use NoSQL or non-RDBMS DB. So in the next slide, I will cover a very lightweight overview on those things, and then we're not doing dive deep anything, just cover the overview of the choices. So when to use SQL? You want to use SQL when you are working with complex queries and reports. Imagine you're thinking you'll be having a lot of tables and you'll be generating a lot of reports and you will be doing a lot of complex joins, queries, views, and you want to support a high transactional application. You need to ensure that your asset compliance and also you don't anticipate a lot of changes and explosive growth, right? So when we think about RDPMS, we think about the data first, we think about the data model, and based on the data model, we build a UI layer on top of the data model, right? So basically, when we talk about NoSQL, the shift has changed. Now, with the NoSQL, we think about the application first and the data comes later. So that means we think about, okay, whatever data we need, we could use one of those multiple choices of NoSQL DB to serve our need. So when we think of NoSQL database, there are many categories, but these are four major ones. One is a documented oriented database. So in this way, in this basically you can imagine all the relationship that you're thinking in RDBMS world could be as part of one single document. A JSON document contains everything, right? So it's basically it gives you a similar kind of flexibility of querying the SQL, and but it's kind of it's in one single document, right? So MongoDB is a very high consistent database, depending on what you're looking for. If you want a key value store, basically think like a hash map, where you given a key, you get a value. DynamoDB is one of the choices. And if you're looking for high availability document store, the data store, then Cassandra is one of your choices. And if you're looking for a graph, where basically you think about your building a connections of networks, let's say you're dealing with a freight forwarding world, you have ports, you have terminals, yeah, you have a lot of moving parts. You could think about having a graph stores. Okay, this is basically come from the CAP theorem that is beyond the scope of this discussion. Now we move to the next slide, and okay, so let's say we have finalized our DB, everything is working. Now the problem with the previous design was we had only one database. What happens if my sorry, we had one web server. What happens if one of the web server goes down, or maybe we are making an update? So for that duration, our website is not available. In that case, we can think of instead of having one web servers, we can have two, or let's say in this case, we're just saying let's say two web servers. And what we need to do when we put two web servers, we need to have some kind of load balancer component. And the job of load balancer is to distribute the load between a number of servers that we have. Now in the next slide, we'll see all the different load balancing algorithm. Now, even though I'm saying all, these are like a more common one. So one is the least connection method. In this one, load balancer identifies the server that has lower number of connections, and it redirects all the new requests to that server. The other thing is, other one is the least response time method. In this case, the load balancer determines which server has faster response time, and it basically redirect your request to that box. And the most common one was a round robin method. Here, basically, you think about all your servers in a circle, and round robin is going to the next available server, like in a round robin fashion, like a clockwise. And the third approach is like the fourth approach is IP hash, and this basically your load balancer is taking the hashing the IP address, and based on that, it's kind of sending the request to the one of the servers. Okay, so now we have database, we have a load balanced web server, all good, but that's not it, right? What happens if your database goes down, right? Since in the previous design we had one database. To overcome that, now we think about, okay, how about this? We add one primary and one secondary DB, and you could think, depend on your design, you can say all the writes an update will go to the primary, and all the read will happen from the secondary, or you could read from both DB, right? But in this case, you are only writing on the primary, so all the write always goes to the primary, all the read is happening from secondary. So now, basically, when we are thinking about having a primary and secondary databases or database, then normally people put more than one secondary DB, because think about what happens if the secondary also goes down, right? So in this scenario, you think you have a primary database, all the writes coming there, and you are doing the replication from your primary DB to the secondary databases, and all the reads are happening from here. So basically, your loads are distributed. If your primary goes down, or even one of the secondary goes down, you have the other secondary databases that can take over and become a primary. Again, now fourth challenge is basically to talk about the performance again. So in the previous design, we have seen that all the requests are coming on the databases every single time. But let's say if it's coming to the DB every single time, and you're running the same query every single time and returning the same result, it doesn't make sense to go to the DB every single time. In that case, you might think of adding another server or another system, uh, let's say Redis cache or any kind of caching mechanism where you can store the data that doesn't changes very often, so, right? So imagine you are making a query to the DB, your data, your server first goes to the cache. If it's not available in the cache miss, it goes to the database, fetch the data, and then store in the cache. So the next request will go to the caching. Now, how often the cache will get updated, how your cache will get evicted, what will be, how can you keep the caching and the DB in sync. Those things are out of the scope of this presentation. I'll cover on this some future presentation. Now we have the caching thing done, all good. Now imagine when you have a website, you have a lot of static contents, right? For example, your JavaScript, uh, your CSS, you have images, you have pictures, you have some part of the of a text or things like that, that you imagine it's kind of it's static. It doesn't changes very often, right? In that case, what you could do is to reduce the load on the server, you could have another CDN. This CDN could be S3 bucket, Azure Blob, or dedicated CDN machine, CDN provider, where you push all the static contents, and when the request comes into your web server, basically all the static contents gets pulled from the CDN. So that solves the static content problem. And then now since we have multiple servers, now we have an issue with the state management, right? So imagine if you as a user is interacting, making some kind of purchases where you're adding item to the cart or selecting something and searching something, you clicked on one of the item, and then suddenly the server went down, right? What happened? You lost your interaction there because the state was there, right? So there are two ways to solve the problem. One is uh, basically you all the requests goes on same box every single time. But in this case, what happens is if that box goes down, you lose everything, and you don't want to have a strong affinity from the client and the server, right? Like from the user to the server. So in that case, you want your web server to be stateless, right? That means it doesn't matter how many times the request is coming. Any of the server who's available can get the, can should be able to process your request, right? Now the challenge is a state. Where did you leave the last box, right? In that case, you could think of having another layer. It could be like a NoSQL database or another caching where you're storing the state of the last interaction that user has made. So when the user come back online or make another request, you know where the user last left and basically return the response from there, right? Now let's go to the next slide. So basically what we saw in the previous slides, if I go back, so we have everything working. We have the web servers, we have database, everything is working. That's fantastic. But now what happens, let's say this particular rack or this particular data center where your machine is, it goes down. That means the entire system is down. Nothing is available, right? So you have to think about how can I make sure that my service is always available. One of the things you could do is you can have like a multi-region deployment. So let's say in this case we have a deployment on US West and US East data center. And let's say one of the data center went down because of emergencies. It could be anything. You could transfer all the load from that data center to let's say the another data center that's available. So you are avoiding a single point of failure, SPOF, right? So you want to avoid that. Uh, so that's where you want to make sure that you are always 100% available. The other problem is, again, even though let's say now your site became very popular, now you're getting, let's say, uh, thousands and hundred thousands requests per minute or second, right? How will you handle that kind of load? So let's say customer have placed an order and you want to process the order, but your database is overwhelmed or there is some issues, or maybe you want to send customer notification on the phone or text messages or email. You don't want your user to be waiting for to receive the text message or to receive the email. You can push all those things in a queue, and you could have a worker thread or worker process or worker machine that basically goes through the queue and process the messages. Messages could be complete the order or maybe charge the customer, send customer an email or a text notification or anything like whatever we want to do, we can put into the queue, like put into the asynchronous processing, right? Uh, again, there are a few more challenges and then we'll be done. One is basically the DB challenge, right? So imagine like we are talking about having primary databases and secondary databases. Now the issue is, let's say if you have millions and millions of rows in one database, and when you're querying every single time, that kind of makes your database slow, right? Because now you're going through the multiple or when you're finding a query, you are basically going through the entire rows. You may be doing a index or a seek, and you're getting the result, right? So one way to avoid this, what you could do is shard your databases into different, like break your database into different partition, right? So one of the way to think about is basically you think like you have one database. Let's in this example, let's say you have four databases, right? And you thinking about breaking your database into four pieces, right? And you could pick a key. For example, you can say user ID. So user ID, you do a mod. Based on the mod, you basically store that particular user information into one of these databases. Now you could say in this design, what happens if the database zero goes down? Again, in this case, what we are doing is, even though our database is down, each of these databases has its own primary and a set of secondaries, right? So let's say if the database zero, the primary went down, there'll be multiple secondaries on this particular shard that will take over, that will become primary. So that way we can overcome. So basically, we are not only doing a sharding, but we are also having the primary and secondary databases, right? And last but not least, whenever you're building a website, you should always think about logging, having a metrics, monitoring, and automation, right? You want to make sure that your system is working as it's supposed to work. If you have a failure, you need to be able to go to the log and see what happened. You need to have monitoring to detect any abnormalities in the system to see if there's a system failure happened. Or you could also have proactively have monitoring. You could detect before even system fails because you have got alerting in place when it happens, right? This is kind of a loss. Basically, think about it. There are 8 things you need to think about. One is you need to keep your web tier stateless. You need to build redundancy at every layer. So remember, like in all my previous slide, we had one common failure, one single point of failure. If you haven't guessed so far, it's a load balancer. So we had only one load balancer. What happens if the load balancer fails, right? Then the entire system goes down. So you need to think about building redundancy there also. You want to cache data as much as you can, right? Basically, of course, you don't want to cache the entire DB. Depending on the scenarios, you could, but you want to cache as much as you can. You need to support multiple data centers. So if one of the data center goes down, you can get data from another data center. Uh, all the static content should go to S3 or blob storage or CDN. It should come from there. Uh, you want to scale your data tier by sharding and split tier into individual services. And last but not least, monitor your system use and automation tools. And this is one of the site I just saw. Is a tool factor net. So go there and you can get more of the things that you need to consider when you're building a new microservices. Okay, thanks. Bye, guys.